Hello there, this is Team Hephaestus, and we built a self-balancing robot.
Our goal was to bring BB-8 to life, turning the character from the movies and our imaginations into a real working robot. We used SolidWorks to build our robots. SolidWorks is a 3D computer-aided design software used by engineers and designers to create, simulate, and manage detailed mechanical models and assemblies. First, we sketched and planned our chassis design in our notebooks. It was originally meant for 2D cutting, but we found that it didn't meet our thickness requirements. So we decided to create a 3D model instead to get a more accurate and functional design. In our original idea, we designed a chassis that clipped together, which worked well at first. However, we realized the electronics were too tightly packed, making it hard to work inside. To fix this, we increased the size and redesigned the chassis so that the floors could slide out separately, making it much easier and more comfortable to access the components.
These are the electronics components that we use for our robots. First is the Arduino. Arduino is the brain for our robot. Second is the motor driver. Motor driver helps us power up the motor and also get signal from the Arduino to control it. And then our power source is the 7.4 volt battery. And then the connection that we use is a breadboard. Help us connect all the circuit that we need to connect. Also, we use a gyro sensor slash accelerometer. That'll help us telling the Arduino that to balance itself.
There were some issues with the first couple of our iterations, but we pushed through and figured out the correct way to install the components. The code structure we used was a modified version of code published on Circuit Digest. It requires 3 libraries to be included in the Arduino IDE: the PID, the MPU6050, and the I2C dev master library. The latter is needed to include the MPU6050 library. In order for the robot to self-balance, the principle of PID is followed. Pause this video to learn more about these concepts. There are 3 PID values, KP, KI, and KD, that we input into the code that the gyroscope reads in order to achieve self-balance. With a uniform and evenly constructed bot, you could manually calculate the correct KP, KI, and KD values, but for our bot, we fine-tuned our code to find the correct values for self-balance. There are 4 main sections of code. First is the section where we include our components, PID and set point values, and the libraries. Second is the void setup section, where we input offset values, which are individual to each MPU 6050. Third is the void loop section, where the PID process happens, which tells the wheels to move. Finally, the last section is made of 3 smaller void sections: forward, reverse, and stop, which tells which specific wheel to either turn on or turn off. Thank you for watching.